Hey guys, it's Mrs. Butcher. This video is about applying the counting principle and about permutations. But before we get to this, I'm kind of hungry, so how about we go get some breakfast? Alright, so I'm down at a coffee stand here. They don't have a very good selection, but they do have donuts and muffins and bagels. And I'd like to get a drink too, but all they have is plain coffee and orange juice. So, of these three foods and these two drinks, how many different combinations of breakfast could I have? Okay, now one way to figure this out would be to make a tree diagram, and you can do this by writing the words, or I'm going to do it with the pictures, but we could make a diagram of all the combinations that we could have. For example, if I bought a donut, I could have a coffee with it, or I could have juice. If I bought a muffin, I could have coffee with it, or I could have juice, or I could buy a bagel and a cup of coffee, or a bagel and some juice. So here are all our combinations of breakfast. If you count them up, there's 1, 2, 3, 4, 5, 6. There are 6 things I could have for breakfast this morning if I can have one food and one drink. So now here is my little way of seeing if you're actually watching this video. In your notes, and even if you printed them and then you're watching the video, you need to write down that Mrs. Butcher wants a bagel and coffee for breakfast. Alright? So now if you don't have bagel and coffee written down in your notes, I know you just copied these from somebody else or you printed them out and didn't watch the video, which isn't going to do you any good because my printed notes are just not anywhere near as great as my speaking notes. Alright, so now it's lunchtime. You're going to buy pizza. You have a choice of 3 crusts, 4 cheeses, 5 meat toppings, and 8 vegetable toppings. And they have a special deal where you choose one of each of those things. How many pizzas with one of each could you choose? So I could make a big tree diagram with this, with all the 3 crusts, 4 cheeses, 5 meats, and 8 vegetables. But that would take forever, and it would be huge. It would be just a gigantic pain. So instead of doing that, we're going to use the fundamental counting principle. And that says, if one event can occur in m ways, and another event can occur in n ways, then the number of ways that both events could occur is m times n. And if we have 3 or more events, it's still the same thing. It can be extended. For example, if you have 3 events that occur in m, n, and p ways, then the number of ways that all 3 could occur would be m times n times p. So I've got my pizza. I've got 3 options for crusts. I have 4 options for meats. Cheeses. I have 5 options for meats. And I have 8 vegetable options. So if I took each of those and multiplied them all together, then I would get 480. And that's how many different pizzas I could have, 480 pizzas. So that's the 480 different types of pizzas that I could make out of those choices. And like, what if we said, okay, well, take the crust out of the equation. We don't get a choice in the crust. Then you would just take out the 3 and just multiply the 4 times the 5 times the 8. If that crust wasn't an option, then we'd only have 160 different pizzas. Say no crust option. But it's pretty simple. You just take the different combinations and you multiply them together. Alright, so a small town, has telephone numbers that all begin with 329, followed by 4 digits. How many different phone numbers are possible if A, the numbers could be repeated, like 5555, or B, the numbers cannot be repeated? So if you look on my little diagram here, my phone, there are 10 different options for each digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So we've got 10 choices per digit. We have 4 digits to fill in. So what we're going to do is we have 10 choices for the first one, times 10 choices for the second one, times 10 choices for the third one, times 10 choices for the fourth one. When we do 10 times 10 times 10 times 10, which is the same thing as 10 to the fourth, that gives you 10,000 different phone numbers. Which is good to know if you work for the phone company. Now, if the numbers cannot be repeated, that changes things. Because you have 10 choices for your first digit, but if you can't repeat, you can't use that number again. So for your second digit, you have 9 choices. And then you've used 2, so now you only have 8 choices for your third digit. And you only have 7 choices for your fourth one. So what that means is we're going to multiply 10 times 9 times 8 times 7. And when you do that, you'll get 5,040 phone numbers. And I don't know why you couldn't repeat numbers in a phone number, but maybe they had a law. I don't know. Alright, now we're moving on to something new. Permutations. So that is a big vocabulary word for you today. Permutations. An ordering of n objects is a permutation of the objects. So permutation is when the order of these things is important. Okay? For example, there are 6 permutations of the letters A, B, and C. We could write ABC, ACB, BAC, BCA, CAB, or CBA. Those are 6 different ways to write the same combinations but in different orders. So you can use the fundamental counting principle to find the number of permutations of A, B, and C, because you have 3 choices for the first letter, and then 2 choices for the second, and then 1 choice for the third. So you do 3 times 2 times 1, and you would get 6, and that's 6 choices up here. 3 times 2 times 1 is something that we can write as 3 factorial. This little exclamation point, it means factorial. It doesn't mean a really loud 3. We just say 3 factorial. In general, n factorial is defined where n is a positive integer, any number, and this is the technical definition. It's n times the next lower one times the next lower one, and so on until you get to 1. Basically like 10 times 9 times 8 times 7 times 6, all the way down to 1. The number of permutations of n distinct objects is always n factorial. And it's no secret, your calculator will do factorials for you. Just press the math button and then choose the PRB option, and then choose option 4, which is an exclamation point. So your calculator will do that. You don't have to do the really big ones. You know, you don't have to punch 99 times 98 times 97. You don't have to do that. Alright, so 8 teams are competing in a baseball playoff. See, look, there's my cute little boy playing first base right there. And how many different ways can the baseball teams finish the competition? Meaning, you know, Cardinals, and then the Cubs, and then the Red Sox, or Cardinals, and then the Red Sox, and then the Cubs. In how many different ways could we have all those teams, all 8 teams finish? In how many different ways can 3 of the teams finish first, second, and third? How many different ways could we have that happen? So we're going to use the permutation rule. So for A, for 8 spots, 8 teams, there are 8 factorial different ways, right? 8 teams could be number 1, and then 7 teams could be number 2, and then 6, and so on. So you do 8 times 7 times 6 all the way down, and 8 factorial is 40,320. 40,320 different ways the teams could finish. That's a lot for 8 little teams. And then B, how many different ways could 3 of the teams finish first, second, and third? So first place could be 8 of the teams, right? Second place could be 7 of the teams because one of them's already gotten first. And then third place could be 6 of the teams. So we just do 8 times 7 times 6. There are 336 different possible combinations for first, second, and third place. So that's where this formula comes in. The permutations of n objects taken r at a time. The number of permutations, remember that means the order matters, of r objects taken from a group of n distinct objects. That's just like what we just did with 3 places out of 8 teams, is denoted by NPR and is given by this formula. So here's one you need to know, NPR. That equals n factorial over n minus r factorial. And yes, you can do this in your calculator. I'll even show you what buttons to push. You hit Math, then you choose PRB, and then you go to option 2, which is the little NPR. Oops, thought I had the pen on. NPR. Anyway, so your calculator will do it for you. But you do need to have this memorized. I am going to look for your work on the paper. So use that calculator to check your work by all means, but you must show your work. You must memorize this formula. Alright, so you've got 7 homework assignments. I don't have a pretty picture to go with this one, sorry. To complete over the weekend. Seems a bit excessive to me. I don't know, maybe you were absent. Let's pretend you were sick and you have a bunch of makeup work. However, you only have time to do 4 of them on Saturday. In how many orders can you complete the assignments? In how many different orders? So we could do math, science, English, or math, English, science, or how many different orders could you complete those assignments? And why you would need to know that, I don't know. Maybe you're just procrastinating so that you don't have to do any of them. But we have 7 homework assignments, so N is 7. 7 objects. And they are taken 4 at a time, so that's your R. R equals 4 at a time. So we are doing 7P4. And remember, NPR is n factorial over n minus r factorial, so 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial, and that is 5,040 divided by 6, which is 840 possible orders that you could complete your homework assignments. Okay, now we have one more thing to do. It's a little bit harder, but that's okay. Y'all ready? Permutations with repetition. That means that the number of distinguishable permutations of n objects, where one object is repeated s1 times and another is repeated s2 times and so on, is n factorial over s1 factorial times s2 factorial and so on to however many repeated objects you have. All right, so let's do an example problem. Let's find the number of distinguishable permutations. Distinguishable, that means like different ones that you can tell the difference between, of the letters in soccer and then in swimming. So it's saying how many times, like if I rearrange the letters, like for example earlier we did ABC, ACB, and so on, there's a C that repeats here. So does it really matter if I switch these two C's? If I switched this C and this C, it would not be distinguishable as a different permutation. So we have to take the number of letters, and is 6 letters, and then C repeats twice. So if we were just, if all the letters were different, 6 factorial would suffice. That would tell us how many different permutations there were. But since C repeats twice, we have to put over 2 factorial. And so we've got 720 over 2. And it's gone, sorry, 720 over 2, which gives us 360. So if they were all different letters, it would have been 720 different ways. But since the C repeats, we have to divide that by 2. So it's only 360 different ways because we can't distinguish one C from the other. Now for swimming, same thing. Our N is going to be, there are 8 letters in swimming. However, the M is in there twice. So that means that little s1 is 2. And the I, see the I right there and right there? I is also in there twice. So S2 is also 2. Like if I had a letter in there 3 times, that number would be 3 instead of 2. So to solve this one, I'm going to have to do 8 factorial on top. And then on the bottom, I do 2 factorial times another 2 factorial. So 8 factorial is 40,320. And then 2 factorial is 2. So 2 times 2 Basically, we're dividing it by 4, and we get 10,080. So it's a fourth of what it would have been had they all been different letters, because 2 of them repeat twice. And that is it for this long, difficult video. And I thank you all for watching, and I'll see you tomorrow.